Hello and welcome to the video. In this video I'm going to be talking about solving two questions. These two questions are from the chapter Triangles of 9th CBSE. I found these questions to be very interesting, and I thought, okay, let me make a video so that students can watch it and understand how to solve these questions. Sometimes in mathematics, especially when trying to prove congruency, similarity, and so on and so forth, there are certain constructions that you need to make, okay, for some particular questions. And if you do not know the construction that needs to be made for the question, you might find it difficult to solve it. And these are such questions where you need to make some constructions to solve it. Let's look at the first one. So the first question talks about a right triangle, and he says that it's been right triangled at A, which means the right angle is at A. He also further tells me that AB is equal to AC. AB is equal to AC would simply mean that this is a isosceles right angled triangle. That's what it means. Along with that, he says that the bisector of C intersects the side AB at D. Prove that AC plus AD is equal to BC. I'm quickly going to write given, to prove, and proof along with the diagram. So that's your given and to prove. So the construction that we need to do here is to draw a line D, let's say E, and this line DE is going to be perpendicular to BC. That's the construction, okay? All right. So what's the goal here? The goal here is to prove that this triangle and this triangle are congruent, right? I'm trying to prove that triangle ACD and DCE are congruent. Now, how is that going to help me? If I can prove that these two are congruent, my goal is to prove that this line here, AC, is equal to EC. Further, I would like to prove that BE is equal to AD. Okay, so if I can prove that, I'm done with the proof. So by proving congruency, I should be able to do AC equal to CE directly. But for proving AD is equal to BE, we need to take a longer route. Let's see what that means. First, let's go ahead and prove that the triangle ACD and DCE are congruent. In triangle ACD and DCE, well, I already know that angle CAD will be equal to angle CED, and that's equal to 90 degrees, which is because one, it is given, and then there's a construction that's happening. So because of those two reasons, I know that they are equal. Along with that, I also know that angle ACD is equal to angle DCE. Now this is given to me. Why? Because CD is an angular bisector, and therefore these two angles are going to be equal. Well, and then I have CD as a common side. CD as a common side. So basically, when I generally do this when I'm proving congruency. I draw two smaller triangles, which helps me to maintain the correspondence and get the correspondence correct. Okay, I would suggest you also do that. It's going to help you a lot. So I know that CAD is equal to CED, and then ACD is equal to ECD, and along with that I have CD as equal to CD. So these two triangles are going to be congruent by the criteria AAS. Therefore, triangle CAD is congruent to triangle. C is corresponding to C itself, A is corresponding to E, D to D. So that's AAS criteria, which would imply that AC is equal to CE and AD is equal to DE. Both CPCT, and I'm going to call this as equation 1. Let's now look at the complete triangle ACB. I've been told that AC is equal to AB. That's a given information for me. AC is equal to AB is given to me. What would that mean? It would mean the base angles are equal, which is this and that angle. They both are going to be equal. So, and because the base angles are equal, they're going to be equal to 45 degrees, and that based on the angles and property. All right. So I can now say angle ACB is equal to angle ABC, and that's equal to 45 degrees. Let's now focus on the triangle DEB, the smaller triangle DEB. Okay. So in that triangle, angle EBD is 45 degrees and angle DEB is 90, and that would mean angle EDB as equal to 45 degrees. Again, angles of property, which would also imply that that triangle DEB is isosceles in nature. And if it is isosceles in nature, DE will be equal to EB. DE is equal to EB. So this is my second equation. So let's look at what we have proved. We have proved that AC is equal to CE, and I have gone ahead and proved that AD is equal to DE, which in turn is equal to BE. Well, what would that mean? BC can be written as BE plus EC BEC is equal to BE plus EC. However, BE is equal to DE and DE is further equal to AD plus EC, which is equal to AC. So that's your proof. So again, in this question, if you do not know the construction, which is DE equal to DE perpendicular to BC, you will find it difficult to solve it, right? And because now you know it, you might find it easier to solve questions of this type. All right, let's look at the second question. Right, again, in this question, he doesn't have to give you the diagram. All right, you can always make the diagram with the information given from the question. There will be certain questions for which you definitely need the diagrams, not for this one though. Okay, so here we have a triangle. Again, it's a right angle triangle. Right angled B, and let's say BC, this is C, and this is, let's say, A. So let's take this as X, and if that's a X, he says this angle here, sorry for that, this is going to be a A and this is going to be a C. This is going to be a 2x, right? Show that the hypotenuse, which is AC, I need to prove that AC is twice of BC. Again, for this construction, for this question, you need to know the construction. Otherwise, it will be difficult. I'm quickly going to write given to prove and proof. So the construction for this question is to draw a line, let's say AD. Okay, I'm going to be drawing a line AD such that angle DAB is equal to angle BAC. Okay, so I'm drawing a line DAB in such a way that I'm drawing a line AD in such a way that this angle is also X, which is basically that they are equal. So let's see how to do this question now. So what I'm going to do is to consider the two triangles, which is ABC and ABD. Alright, so one of them is a 90 degree that I already know, and angle BAC, which is X, is also equal to angle BAD. This is due to constructions, and I have AB is equal to AD, AB is equal to AB, which is a common side, and that would mean that these two triangles are congruent using the criteria ASA. So what if it is congruent? Well, because it is congruent, I can now conclude that AD is equal to AC, CPCT. Therefore, AC is equal to AD, CPCTC, or CPCT. That's also fine. Now, what would that mean? What would that mean for the triangle ADC? That would mean that the triangle ADC is isosceles, hence angle ADC is equal to angle ACD, and that's equal to 2x. So this is also 2x. Now you please note that this angle is also 2x, this is also 2x, and that's also 2x. That would mean that the triangle ADC is equilateral. Triangle ADC is equilateral. Therefore, can I now say AC is equal to DB? Right? AC is equal to DC. But AC can now also be written as DB plus BC. Now there's one information I forgot to mention here. Under this, I can also say BC is equal to BD, CPCT. So BC is equal to BD, so I can write this as BC plus BC. If I can take this as 1 and then write the reason as from 1, that would prove that AC is twice of BC. AC is twice of BC. A very interesting question. Again, if you do not know the construction, it might be difficult for you to solve this. So we've solved two questions. We have solved two questions here. First question talks about a right angle triangle, right? And then it talks about AD being the angular bisector. We had to prove that BC is equal to BE, which is AD actually, plus AC. What did we do? We proved congruency between these two triangles, right? And after proving congruency between these two triangles, we went ahead and confirm that AC is equal to BE, AD is equal to DE, and then we went ahead and said, you know what, this is an isosceles triangle. Yes, this is an isosceles triangle, correct? And that would mean that the base angles are going to be a 45, which means this angle was a 45 and this angle was also a 45 degree. And then we focused upon the triangle DEB, which is this triangle here, right? And in that triangle, we mentioned that the base angles are 45, again using angles and property, and that would mean that it's isosceles. And because it's isosceles, this was supposed to be, this is equal. And that was my proof. A pretty simple proof. If you know the construction, it's going to be easier. The next question also involved a construction to be done. Once I know the construction, how to go about doing the question, it's much simpler. We proved that these two triangles are congruent. The construction was basically to consider or drawing a line AD such that DAB is going to be equal to, right? So those were the two questions that I wanted to solve for this video. Thank you very much for your patience. That's it for this video. Thank you for joining. Goodbye.